Okay, so we've got a current flowing in this wire, right? And it's either going clockwise or anti-clockwise in this wire. But it's doing it such that there's a force of 3.2 newtons this way. How do we know that? Because we've got a little pulley there, and we got 3.2 newton mass, a 3.2 newton weight here, and it's pulling down this way 3.2, so there must be a force of 3.2 that way, right? So let's look at this stretch of the wire right here. How would we have a force of 3.2 to the left on this wire here? Well, my force is that way, so let's put our thumb that way. Thumb to the left. Okay, put your middle finger out of the page. Okay, so thumb to the left, middle finger out of the page, right? Because that's the magnetic field. Equals thumb equals out of the page, right? Okay, so thumb is to the left, middle finger's out of the page. My index finger is pointing down the page. So the current is flowing in this stretch of wire that way. Of course, here it's flowing that way, here it's flowing that way. And in general, in the loop, it's flowing anti-clockwise. Okay, so that's how we get the answer anti-clockwise. Okay, and then the numeric answer is actually not all that hard. Now you say, I only looked at this part of the wire, and you're like, well, why did I look at only that part? Well, here's why, right? Here's this part with an unknown length, right? We don't even know this length, right? Okay, but look at this part. Index finger this way, middle finger out of the page. Okay, that force would be this way on this wire, right? And if we do this guy, if we do the opposite of that, and I do the same length and the same current on this stretch, the force would be exactly equal to this force, okay, but it would be down. So the upward and downward forces counteract each other, right? They would, by the way, this loop would tend to like expand if it was made out of a flexible material. It would tend to try to make itself into a circle, but let's assume that doesn't happen, right? Okay, and the net force would be 3.2 newtons. Now imagine that it was like a circle, right? Really all that would matter would be this dimension here. You could show that with calculus, but that's the way it works out, right? So if this was 1.5 and it was like a loop or something like that, it would be just like this. It would be exactly like this. The shape of this wire doesn't actually matter, okay? It would just be, as long as you had 1.5 where it exited, it was 1.5 meters. And the B field actually did stop like that. It wouldn't matter. Okay, you could do all the calculus, and these forces would be all like all this direction, right? But it would all add up to the same. Okay, so now we can solve for the current, right? F is ILB. Theta is 90 degrees, right? So 3.2 is equal to I times 1.5 times 0.25. And then we can just solve, right? So 3.2 divided by 0.25 divided by 1.5. And I get 8.53. Ta-da.